All right, so in science class, what did you guys say a variable was? Just general definition of a variable.
Oh.
The variable is
That's a
It can what?
That's an independent.
independent variable is the one you can control.
Okay, so we had a different, in science class, you got a difference between independent and dependent. But what does variable mean? Just all by itself, not with the independent, dependent piece with it.
Oh. I have no idea.
Okay, what do you see at the beginning of the word variable here? And I know it's an I, so make that I a Y. Vary. When something varies, what do you say about it? It can, something that can change, says Peyton. So in math class, we're going to use variables, and they're going to be something that can change. And how we're going to talk about the something that can change is we are going to make it a letter in math. And I know you just touched on letters last year in 5th grade. So our definition of a variable is going to be a letter or symbol that represents a number. And the book uses the word quantity, but I wanted to use the word number because I think that would make more sense for you guys. A number that can, and I'm going to underline the word can, change.
So it's an independent variable.
So in math, it could be an independent or dependent. Okay? It's something that can change.
So it's an independent.
So in science, you guys talked about independent, dependent. The independent one was the one that you changed, right? And the dependent one was the one that changed because you changed something. So now we're just going to lump them together as a variable all together. And it's a number or symbol, a letter or symbol that represents a number that can change. Constant. I know you also talked about constants in science. So what is a constant? You didn't talk about constants yet?
No.
Okay. Well, okay. Did you talk about controls?
Yeah.
They're the same thing. Okay? A constant or a control is something that you can control, but do you change it in your experiment?
No.
No, you don't change it. So a constant in math is going to be a number that does not change. Okay, so we're not going to change the constant. All right, who remembers the last chapter when we talked about a mathematical expression? Do you remember what that was?
You expand it?
Not expand.
Okay.
I'm going to write an example. You guys don't need to write this down so you can get an idea. A mathematical expression was like 5 plus 2. That's a mathematical expression. You remember those? Okay. It's got numbers and then an operation symbol. So the plus in there, or 5 divided by 2, or 5 minus 2, or 5 times 2. That's an expression. Now we're going to talk about an algebraic expression. So an algebra, you learned some of this last year. Good. An algebraic expression is a math expression. Okay, it's going to be a math expression with, so it has to have one or more variables. And I heard Zach up here, it says writing variables. Before I said wrote variables, he said letters, right? Yeah, those variables are going to in the form of letters. So that's like our letters here. Okay? Variables or letters. And because it's an expression, it's going to have a plus, a minus, a multiply, a divide, some sort of operation as well. So an example of that would be 150 plus y.
What?
That's an algebraic expression. It's a math expression, and it has a variable in it.
We learned this, but I'm so horrible. I have
Okay?
what is the
That's why we're going to get more practice this year, Happiness.
okay.
These are so fun.
So another example might be 35 plus W plus 2.
What does the W mean?
What does the letter stand for? That's our variable. So we could plug different numbers in there to get different answers.
Yeah, normally they give you the answer and you have to find what W.
Yeah, is that what you did last year? They gave you like 150 plus Y equals 200.
That could be
You had to figure out why?
552.
We'll be doing some of that too. Okay?
I thought we told the opposite.
You're wrong. It's
So,
552.
Zach, today we're going to focus on one variable expressions to start. So an expression that just has one variable, so one letter in it. And I've got a table set up here. This is one way to organize information.
Oh, I know.
So our variable for this one is going to be a W. And our algebraic expression for this one is going to be W divided by 11. So Olivia said, well, I don't understand. What is the letter supposed to be? So we're going to put some numbers in there. The book is going to either give you some numbers. They're going to say W, let's say W equals 55. So you would do 55 divided by 11 equals 5. So I took the 55 and I put it in the place of the W.
The value is 55.
And what if they gave you another one? What if they said 66 is going to be W? So now you'd put 66 in the place of W. 66 divided by 11 equals 6.
7.
Let's try another one. 77.
Well, that's an amazing number.
So what's my W now?
77.
77. So 77
That number.
divided by 11 equals 7. What was my constant in that problem?
11.
11. That's the number that never changed. Okay? So my variable was my W, and that changed. I told you what W was going to be each time, and you replaced it, you substituted it in there. Okay? Let's do a letter B here is going to be a little bit more difficult of a problem.
Do you have an answer key right there?
I do. We're going to use N as our variable this time. So N is going to be our number. And we're going to, here's our expression, 4 times N plus 6 squared.
Squared mean.
What does squared mean again?
2. No, it's not.
What does squared mean again, Grady? Do you remember?
You times it by 2?
Not times it by 2.
Cube.
When it's an exponent, what do we do?
Oh!
What do we do when it's an exponent?
You go 6 times 6.
6 times 6, yes. So, in this one, we've got to follow order of operations, right? So what's my first operation I'm going to do? Mason?
Exponent,
The exponent. So first I'm going to do 6 times 6. Okay? So what I'm going to do is we're going to fill that in each one of these boxes below,
36.
because every time that's going to remain 36, right? That's not going to change. That 6 times 6 is always going to be there. Now let's put some numbers in. Yeah.
I got a question.
Yep.
For that, do you just choose a random letter and just put it there?
Typically they'll pick a letter that represents maybe what they're talking about. So if they're talking about apples, they might use A. A lot of variables you're going to see are X's and Y's. Those are probably the most common used variables in math. You will get to pick the letter a lot of times. For this assignment, the book will pick the letter most of the time for you because they'll give you an expression already. When you're taking a story problem and creating your own, though, you could pick the letter.
It's going to take forever.
Yeah. So if you wanted to use X or Y or N or A or B, you can do that. Okay? All right, so let's put some letters in for N. Let's make N worth 1 here. So what's my expression going to be?
4 times 1.
4 times 1 plus 36. And what's my first thing I have to do in this 4 times 1 plus 36? Grady? 4 times 1. What's 4 times 1, Grady?
4.
So we have 4 plus 36. And then that equals 40. So I heard Zach say I did it mentally. Do I still have to write it? Yeah, write it down for your notes so you have record of it. Okay, I know we can do a lot of math mentally, but the more we write down, the more we'll remember for the future. Let's make n worth 2. So 4 times 2 plus 36. What's my first thing I have to do, Peyton? 4 times 2, and the answer to that is? 8 plus 36.
42.
44. And again, I am completely fine if you use a calculator to do that addition. Okay? I'm not testing your adding skills here. I'm seeing if you can figure out how to use algebraic expressions. Let's make it a 3. 4 times 3. Okay, see where we're getting the 2 from?
48. 40. Yeah, I said that. That's what I said. Yeah, I knew that. 48, yeah.
All right, I heard some 48s out there. That sounds right to me. All right, let's remember a couple things about multiplication and division. Remember, you can write multiplication without the multiplication sign. What other symbols have we used for multiplication?
Dot.
So we could say 3 times A. That dot means that. There are other ways also to write multiplication.
How?
You can do 3 parentheses A. If you have a number right next to parentheses, that means multiplication. There's one other way too. If you just have a number next to a letter with nothing there between them, it means multiplication. 3A. That means you have 3 A's. So 3 times A. Those 3 different ways to write multiplication. We can also write division in a different way than you're used to. We don't always have to use the division symbol. Division can be what we call a fraction. So let's say you had 35 divided by A. So when you make it that means division. Aiden.
Won't we also use the slash as
For division, you could also say, as Aiden said here, 35 divided by A. A slash like that. So just a couple different ways that will show up. I don't think the last division one shows up in your homework, but I know all these other ones do show up in your homework. Okay? So just remember those. Okay. Now we're getting on to 2 variable expressions. So here's a problem here. A rectangle is 2 units wide, which is our constant. What is the area if it is 4, 5, 6, and 7 units long, which will be our variables? So do you remember last year at all learning about the formula for the area of a rectangle?
Yes.
Do you remember what it was?
I still don't do that. Oh, isn't it like
What do you think?
side, side, divide?
No? Has to do with the sides though.
Times width.
Length times width.
Times height.
So for the area, it's just length. And I write my L's like this so they don't look like ones. It's a lowercase cursive L. Times width.
Oh, you're writing this in here?
Yep, write it right in that box up there.
What the hell?
Length times width. And again, I write them that way because then they don't look like ones. And I don't confuse myself then. I always use lowercase L's with this formula.
Oh, I was gonna do it.
So then we're going to have our length and our width are our 2 variables here. This is a two-variable algebraic expression. So from the problem above, what do we know about every single one of the rectangles? What's the same about every single rectangle? 2 units wide. So under my width on each one of these, I can write 2. Because that doesn't change. And I could also write that if I want to in my multiplication problem here. My 2's in there. I could fill all those in if I wanted.
No, I wrote it wrong. Oh, wait, I still did it. No, I still did it wrong. Funny, get pranked.
What do I know about the lengths? What are my lengths? Grady?
4, 5, 6, 7.
Wait.
So that is my variable.
That.
So I got my lengths for my problem here, 4, 5, 6, and 7 units long.
Get pranked.
So then I would fill in my multiplication problem with those numbers. So I'm not just choosing random numbers, I'm using the numbers that the problem gave me. So Liam, 4 times 2. 8. Mason, 5 times 2. 10. Aiden, 6 times 2.
12.
Hayden, 7 times 2. 14. What are my units for this? My problem give me units? It's a story problem, so a lot of times they give units in story problems.
Area.
It's going to be area, but what's the word we're going to use for the units?
Unit split.
Yeah, unit squared. So it's 2 units, 7 units, 6 units, 5 units, 4 units. So it's units, and because we're area, it's units squared. So each one of those you need to make sure you have.
Oh my goodness. Is there not an abbreviation for it?
For units, there's not. So if they don't give you feet, meters, inches, a length, a measurement, and they just say units for area, your answer has to have units squared. If they had given you feet, it'd be feet squared. If they gave you inches, it'd be inches squared. But in this case, we just had units, so it's unit squared.
Abbreviations for all the other ones. Did I spell it wrong? No, I didn't. Algebraic expression. Because.
All right, so y is 45 plus x in an algebraic expression. What do you think, Zach? Why? Your answer again, Zach, for 45 plus x. Why is it an algebraic expression? Because it has what?
Variable.
It has a variable in it. Okay? Because there is a variable. That's part of it. Is the letter y an algebraic expression?
No.
Yeah.
There's a variable, though.
The 40.
Mason, what are we missing there?
Constant.
Has a variable. Go back up a minute before you write that.
Go back on the page.
This right here is an algebraic expression. Is there a constant? No. It has what?
The symbol. Oh, letter.
Math expression.
It has it's a math expression. It has that operation because there is a variable and an operation. There's that plus sign in there. If it had 2 numbers, we wouldn't call it algebraic. We'd call it a math expression. right, one last example here. You'll get a couple questions in the book that are written this way, so I want you to know what to look for. That won't be in the table, so there'll be some questions that have a table like we did, but some questions will look like this. Z divided by 8 for Z equals 56. What do I do with that?
What?
What do I do, Peyton?
56 divided by 8.
Yeah, I would write down 56 divided by 8. Okay, so I'm taking my Z, right? And because Z is equal means they're the exact same thing, I can replace
Oh, I don't see that equal.
this 56 can go right where the Z is. So I have 56 divided by 8, and that equals 7. Okay, so you'll get some problems that have, they'll give you the algebraic expression and they'll use the word for
I thought that was
and then tell you what the variable is on there. All right?